Hello my people, in today's program I shall teach us how we can actually derive the quadratic formula using the method, okay, that goes this way. Now let's go. Let me show you, okay, how you can apply differentiation, all right, to derive the normal general formula for a quadratic equation. All right. This is equation A, right? AX squared plus BX plus C equals 0, okay? Now, first up, I form the equation A1. How? Multiply this equation A by a constant 4A, okay? So, doing that, I will have 4A squared S squared, because 4A times A here is 4A squared S squared, okay? Plus 4A times B is 4ABX, 4A times C is 4AC. 4A times 0 is 0. Call this equation A sub 1. I don't want to teach much time. The next thing to do is for me to let in x or y to be equal to what? The left hand side of the equation A. So that I could treat that as a function which is assumed to be what? Continuous. So that its derivative can be found. So I say let y equal to ax squared plus bx plus c equal to what? 0, such that y prime of x is equals to 2x plus what? B. The derivative of a constant is 0, okay? If I differentiate this linear term here, I will have only what? The coefficient, which is what? B, alright? If I differentiate this quadratic term here, I will be left with what? 2a. Don't worry, in my subsequent videos, okay, where I will teach about calculus, you will learn, okay? Just relax, man. Just listen up. Now call this equation A2 equation A3. Now I will have to square this equation A3 and add the result to the both sides of equation A1. If I square that, I will have 4A squared S squared plus 4ABX plus 4AC, then plus the square of what? This, okay? Plus the square of this, okay, which is at this juncture, let me okay, I will have space 2as plus b all squared equal to, all right, the light is affecting here, so if I write something here, it will not be clear, okay? So equal to 2as plus b all squared. Do you see it? I squared equation A3, okay, and add the result to the both sides of equation A1, which is this now, okay? The whole of this plus 2as plus b all squared equal to 2as plus b all squared, alright? So I go, what do? I will make this the subject of the formula by transposing this trinomial here. I'll transpose them to the left hand side, okay? So doing that, I have this as the subject of the formula. 2as plus b all raised to power 2 is equal to the right hand side, which is 2as plus b all squared, then minus, because you are taking this to the left hand side, so the plus sign here crossing over will change to minus, so I have minus brackets 4a squared s squared plus 4a bx plus 4ac. Alright? So, what else do I do? I will have to expand, the 2, okay? So doing that, I will have 2as plus b all squared equals to, by the binomial formula, in binomial series, which I will also treat in my subsequent videos. If you expand this, 2a all squared should give me 4a squared s squared. 2a times b times a constant 2 should give me plus 4abx, alright? Again, b squared is b squared, that is b times b is a b squared, alright? Then, you now use this minus to open this bracket here. So, minus 4a s squared, right? Minus 4a squared s squared. Then, minus plus is minus 4abx minus plus minus 4ac. So at this juncture, do you see you can actually strike out like terms, okay? There are like terms there, 4a squared b, 4a squared s squared, and the 4a squared s squared are like terms. They strike out, plus 4abx and minus 4abs strikes out. I am left with 2ax plus b all squared to be equals to, what am I left with? B squared here, b squared minus the constant 4ac. All right, so let me just clean this to have space. Okay, I clean this. All right, so we go again. Since this one is also a binomial, I'll have to square both sides. All right, to remove this was power 2 here, I will raise the both to the power half, which is simply the squaring of what? Both sides. Okay, so doing that, I'll be left with 2as plus b equal to, because when you raise this one to the power half, the 2 and this 2 here will, the half and this 2 will just cancel out. Okay, so equals to b squared minus 4ac. This is what we call the discriminant of a, sorry, I'll have to put the, because for the equation, for you to maintain the originality of an equation, whatever you do at the left must be done at the right, and vice versa. Okay, so I have the discriminant b squared minus 4ac. Okay, at this point, in Tambuwal Maths of yesterday, there was a video, a very big content creator called Tambuwal Maths, actually use this as a formula. Okay, look at how it was derived, or you can actually, from a normal quadratic formula, you can just clear the fraction there. That's 2a. You can use that to clear the fraction of x, okay? To have 2ax. Then that's minus b. You can just transpose that to the left hand side and you still have what? This, which is simply the first derivative of the left hand side of equation a. It's a very simple thing, alright? So, you can leave it like this if you want, okay? Just as Tambuwal Mathematics left its own, alright? But you can just divide through, okay? Or first of all, take this. This is already the almighty formula, alright? It's just the almighty formula, okay? So you can just transpose this to have 2ax equals to minus b plus or minus root of the discriminant, which is b squared minus 4ac. You can just clear fraction by what? Divided by what? 2a. That's all. Do you see? S equals to what? That is just the general formula. So do you see that if you clear fraction, okay, so 2a times x will give you 2ax plus, then when you now take the minus b to the left hand side, you have the what? Plus b. So actually that was how I got the formula, okay? I derived it myself, alright? Actually I applied the rule of what? Derivative to see if I could actually have the normal quadratic formula, and it works. It works for every quadratic formula, okay? So you can simply have your discriminant here, all right? Once you establish that, you can just take the first derivative of that original equation given to you, just equate their both and solve for x. That's all. So that just it, okay? You see, math is fun once you listen with rapt attention, all right? Please follow my page and subscribe to my YouTube channel, which I normally post the link to my Facebook page, all right? Comment, you can ask your question. Thank you for watching.